The National Electrical Code, specifically the 2005 edition, addresses the conditions under which other current carrying conductors can be run in the same raceway with ground fault circuit interrupter, or GFCI, protected conductors. It's important to understand these rules to ensure safe and compliant electrical installations. The code outlines 4 specific conditions that must all be met in order for this type of mixed conductor installation to be permissible. Let's examine each of these conditions in detail. Firstly, all conductors must be terminated at the same location and share the same grounded conductor. This means that the GFCI protected conductors and the other current carrying conductors must ultimately end up in the same electrical panel or enclosure. They must also utilize a common neutral or grounded conductor. This shared grounded conductor helps to ensure proper operation of the GFCI device and minimize the potential for nuisance tripping. Secondly, the outlet being supplied must be GFCI protected. This condition emphasizes the importance of GFCI protection in these installations. The GFCI device is designed to detect ground faults, which are dangerous electrical conditions that can lead to shock or electrocution. By ensuring that the outlet is GFCI protected, you are providing an extra layer of safety for anyone who may come into contact with the electrical system. Thirdly, the GFCI protected conductors must be contained within a continuous raceway. A raceway is an enclosed channel designed to hold and protect electrical wires and cables. Examples of raceways include conduits, electrical metallic tubing, or IMT, and liquid-tight flexible metal conduit. The requirement for a continuous raceway means that the GFCI protected conductors must be enclosed in a raceway from the point where they originate to the point where they terminate. There should be no breaks or interruptions in the raceway system. Fourthly, the total length of the raceway must not exceed 6 feet. This is a critical condition that often determines whether or not a particular installation is compliant. The 6-foot limit is intended to minimize the potential for inductive coupling between the GFCI protected conductors and the other current carrying conductors in the raceway. Inductive coupling can cause current to flow in the grounded conductor, which can lead to nuisance tripping of the GFCI device. To illustrate how these conditions apply in practice, consider the scenario of a pool light and a motor that are being supplied from the same electrical panel. The pool light is protected by a 20-amp GFCI breaker, while the motor is supplied by a 20-amp 2-pole breaker. Both the motor and the pool light conductors are run through a single conduit that originates at the electrical panel. In this scenario, the first 3 conditions are likely met. All of the conductors are terminated at the same location, the electrical panel, and they share the same grounded conductor. The pool light outlet is GFCI protected. The conductors are contained within a continuous raceway, the conduit. However, the 4th condition, the 6-foot raceway length limit, is likely not met. Since the conduit runs from the electrical panel to the motor and then to the pool light deck box, the total length of the conduit will likely exceed 6 feet. Therefore, this installation would not be compliant with the NEC 2005 requirements. To correct this non-compliant installation, the GFCI protected conductors for the pool light should be run in a separate raceway from the motor conductors. This separate raceway should not exceed 6 feet in length. Alternatively, if it is not possible to run a separate raceway, the GFCI protection could be moved to the electrical panel. This would eliminate the need to run GFCI protected conductors in the same raceway as the motor conductors. It is important to note that these requirements are specific to the NEC 2005. Subsequent editions of the NEC may have different requirements. Therefore, it is always important to consult the latest edition of the NEC to ensure that your electrical installations are compliant. In addition to the NEC requirements, there may also be local electrical codes that apply to your area. These local codes may be more stringent than the NEC requirements. Therefore, it is always important to check with your local electrical inspector to determine the specific requirements for your area. When working with electricity, safety should always be your top priority. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. The qualified electrician will have the knowledge and experience to ensure that the electrical installation is safe and compliant with all applicable codes. Always turn off the power to the circuit before working on any electrical equipment. Use properly insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are unsure about any aspect of an electrical installation, consult with a qualified electrician. Understanding the NEC requirements for running GFCI protected conductors in the same raceway as other conductors is essential for ensuring safe and compliant electrical installations. By following the 4 conditions outlined in the code, you can minimize the potential for electrical hazards and ensure the proper operation of GFCI devices. Remember to always consult the latest edition of the NEC and your local electrical codes to ensure that your installations are compliant. And when in doubt, always consult with a qualified electrician. The principles underlying these code requirements relate to minimizing electromagnetic interference and ensuring proper GFCI operation. Let's delve deeper into these aspects. Electromagnetic interference, or EMI, can occur when electrical conductors are run in close proximity to each other. The flow of current through a conductor creates a magnetic field around the conductor. This magnetic field can induce a current in nearby conductors. In the case of GFCI protected conductors, induced currents in the grounded conductor can cause the GFCI device to trip, even when there is no actual ground fault. The 6-foot raceway length limit is intended to minimize the amount of EMI that can occur between GFCI protected conductors and other current-carrying conductors. By limiting the length of the raceway, you are reducing the amount of magnetic field that can be coupled between the conductors. Proper GFCI operation is essential for protecting people from electrical shock hazards. GFCI devices are designed to detect ground faults, which occur when current flows through an unintended path to ground. For example, a ground fault can occur if a person touches a live wire and provides a path for current to flow to ground through their body. GFCI devices work by monitoring the current flowing in the hot and neutral conductors of a circuit. If there is a difference of 5 mA or more between the current flowing in the hot and neutral conductors, the GFCI device will trip, interrupting the flow of electricity and preventing electrical shock. The presence of other current-carrying conductors in the same raceway as GFCI protected conductors can interfere with the proper operation of the GFCI device. As mentioned earlier, induced currents in the grounded conductor can cause nuisance tripping. In addition, the presence of other conductors can increase the overall impedance of the circuit, which can reduce the sensitivity of the GFCI device. Therefore, it is important to follow the NEC requirements for running GFCI protected conductors in the same raceway as other conductors to ensure that the GFCI device is able to detect ground faults and protect people from electrical shock hazards. Consider different scenarios to further clarify these concepts. Imagine a situation where you are installing a hot tub on a residential property. The hot tub requires both a GFCI protected circuit for the heating element and a separate circuit for the pump motor. You decide to run both circuits in the same conduit from the electrical panel to the hot tub location. In this scenario, you would need to carefully consider the NEC requirements for running GFCI protected conductors in the same raceway as other conductors. Firstly, you would need to ensure that all of the conductors are terminated at the same location, the electrical panel, and that they share the same grounded conductor. Secondly, you would need to ensure that the hot tub heating element circuit is GFCI protected. Thirdly, you would need to ensure that the conductors are contained within a continuous raceway, the conduit. Finally, you would need to ensure that the total length of the raceway does not exceed 6 feet. If the distance from the electrical panel to the hot tub location is greater than 6 feet, you would need to run the GFCI protected circuit and the pump motor circuit in separate conduits. Another scenario to consider is the installation of a swimming pool. Swimming pools typically require multiple electrical circuits for various equipment, such as the pool pump, the pool light, and the chlorinator. Some of these circuits may require GFCI protection, while others may not. In this scenario, you would need to carefully plan the electrical installation to ensure that the GFCI protected conductors are run in accordance with the NEC requirements. You may need to run separate conduits for the GFCI protected circuits and the non-GFCI protected circuits. Alternatively, you may be able to use a single conduit, provided that all of the NEC requirements are met. When working with electrical installations near swimming pools or hot tubs, it is essential to pay close attention to the grounding and bonding requirements of the NEC. Grounding and bonding are critical for preventing electrical shock hazards in these environments. Grounding involves connecting the electrical system to the earth, which provides a path for fault current to flow back to the source. Bonding involves connecting all of the metal parts of the electrical system together, which creates a low impedance path for fault current flow. By properly grounding and bonding the electrical system, you can minimize the potential for electrical shock hazards near swimming pools and hot tubs. In addition to the NEC requirements, there may also be specific requirements from the equipment manufacturers. For example, the manufacturer of a pool pump may require that the pump be connected to a dedicated GFCI protected circuit. The manufacturer of a pool light may require that the light be bonded to the pool's bonding grid. It is important to carefully read the manufacturer's instructions and follow all of their recommendations. Failure to do so could void the warranty on the equipment or create a safety hazard. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. A qualified electrician will be able to assess your specific situation and provide you with tailored recommendations that are safe and compliant with all applicable codes. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always take precautions to protect yourself and others from electrical shock hazards. Turn off the power before working on any electrical equipment, use properly insulated tools, and wear appropriate personal protective equipment. By following these safety guidelines, you can help to ensure that your electrical installations are safer and reliable. In summary, the NEC 2005 places restrictions on running other current carrying conductors in the same raceway as GFCI protected conductors. The 4 conditions that must be met are: firstly, all conductors must be terminated at the same location and share the same grounded conductor. Secondly, the outlet being supplied must be GFCI protected. Thirdly, the GFCI protected conductors must be contained within a continuous raceway. And fourthly, the total length of the raceway must not exceed 6 feet. Understanding and complying with these requirements is essential for ensuring safe and compliant electrical installations.